always be on tentacles. Of course, yes. Today we are going to treat a new topic by name implicit differentiation. Alright, so before you can solve for implicit differentiation, you need to know this step, so you should understand what it means. Step 1, step 2, and what, and step 3. So now, when do we apply the principles of implicit differentiation? You'll be given questions where you see x and y variables at the same time. So you trying to differentiate x and y variables at the same time calls for implicit differentiation. All this while, the type of differentiation you'll be solving, you'll be given, let's say a function of y is equal to, let's say 3x squared plus 5x squared. You realize that they are in one variable, so we don't need to apply principles of implicit differentiation. But this time around, we are going to what? Blend or mix x and y variables together. Hence, calling for implicit differentiation. We can apply implicit differentiation in so many fields. In the case of engineering, economics, and other fields. Alright, that is implicit differentiation for you. Even in a case where you are going to do optimization, you are going to use what? Implicit differentiation for implicit defined functions. So these are the steps. First of all, you have to differentiate both sides of the equation term by term with respect to x. If you are new here, you can kindly visit my previous lectures on how to differentiate simple functions. So as for this, it's very simple to understand. Of course, we've been doing the first one all this while. Now secondly, since y, which is equal to f of x, use the chain rule to differentiate, especially with terms containing y. Remember when we were trying to prove some of the trigonometry functions, how to differentiate the proof, you realize that we got to some aspects where we are supposed to apply implicit differentiation over there. And you realize that when I got to terms containing y, I added what? dy dx. So I'm going to solve them practically over here. And lastly, you have to solve the differentiated equation explicitly for dy over dx. So viewers, we have some questions on the board. So let us what? Appreciate implicit differentiation. So the question is, find dy dx if 1, x squared plus y squared equals 2. In this case, I have what? X and y. I'm trying to differentiate them at the same time. So let's see how it goes. So I have my solution. So I have x squared plus y squared equals 2. I'll differentiate the term containing what? The x first. So differentiate both sides of the equation term by term with respect to what? X. So let me touch on the x first. So when I differentiate x squared, what will I get? I'll have what? 2x, as we've been doing always. Then plus, when I differentiate y squared, you know we'll be getting what? 2 what? Y. But because it is a term containing y, what would I do? I will add what? dy over dx using what? The chain rule, okay? So here we have 2y, y over what? My dx. All because of what? The term y. Which is equal to, when I differentiate any constant at all, we will have what? 0. I have 0. So afterwards, the third step is telling us to what? Solve for what? dy dx. What do we mean by solving for dy dx? It means you have to make what? Dy dx there subject of the relation. Alright? So I'll make dy dx the subject of y. So I have 2y dy over my x equals, then I want to transpose the word to the 2x. So I have a negative 2x. I'll divide both sides by what? The coefficient of dy over dx. So I have what? 2y over 2y over 2 cancels 2, y cancels what? Y. So finally I have dy over my dx, giving me what? 2 cancels what? 2. So I have negative affecting the x. So I have what? Negative x over my y. Viewers, have you seen how simple it is to differentiate this using what? The implicit differentiation, where we have what? X and y what? Variables. So using the same analogy, let's solve for what? The second question. So the second question is, find dy dx if x squared plus xy plus y squared is equal to what? 0. When I differentiate x squared, we have what? 2x. Then plus, we are going to use the chain rule over here again. But first of all, we've talked about product rule, where you differentiate one function, then you leave the other function, then plus you leave the first function and differentiate the second one, as we've been doing under product rule. Viewers, if this is your first time, kindly visit my previous lectures over there where I've taught product rule into details. So here, we are going to apply the same concept over here. I have x and y. I can decide to differentiate x first or y first. So if I want to differentiate x first, I can decide to maintain x, or I can differentiate x first. So let me adopt one. So if I differentiate x, I'll have what? I'll have 1. Then I will maintain my y. If I maintain my y, I have it this way. Is that also? Then plus this time around, I will maintain x over here. Then if I differentiate y, what do I have? I'll get what? 1. But because I'm differentiating y, so there's a term containing y over here. Because I'm differentiating y, I'll add what? Dy dx. So I have this way, dy over dx. Please take note of this. In this first case, I differentiated x, so I have 1. Then the 1 multiplies y. So I don't have to add dy dx because I'm not differentiating y. Then plus, I maintain my x because I'm differentiating y. I added on dy what? Over dx. Then plus, I have what? Y squared. Again, I'll differentiate what? Y squared. So I have what? 2 what? Y. Again, because it is a term containing y and I'm differentiating y, I'll add what? Y over what? Like x, which is equal to what? 0. So I have 2x plus y plus x dy over x plus I have 2y dy over dx is equal to 0. Again, in implicit differentiation, we are going to what? Make dy dx the subject. So I have 2x plus y, then plus I can what? I can factorize. Can factorize this and factorize that. So I have what? So I can close the brackets. I have x, then plus I have what? 2y. Because dy dx and dy dx they are common over here, I'll pick one. So dy over what? Dx. That's simple factorization, which is equal to what? 0. So I have x plus 2y dy over my dx is equal to, then if y, if I transpose positive y, I'll get what? Negative what? Y. If I transpose this, I'll get what? Negative 2x on the other side. Then I'll divide both sides by what? By the coefficient of y over dx. So I have over x plus 2y over x plus 1 2y. So this cancels this. So finally I have dy over dx to be equal to what? Negative 2x minus y all over x plus 2y. Negative y minus negative 2x is the same as negative 2x minus y. Viewers, let me see how simple it is. Okay, so the third one is find dy dx if x multiply the expression x plus y equals y squared. Viewers, I want you to solve this on your own and present your concern or your answers on the comment section for me. I'll consider no one is wrong over here. Just try your best. I will look out for your answers on the comment section. Just the third one, okay? Now I have one last question. If you understand the principles of implicit differentiation, you can solve for those question types. So I have the final question I would want to solve with you. So let's visit the board. Alright? So the question is, if the expression 1 plus s squared multiplying another expression 1 plus s squared minus px squared equals 0, where p is a constant, show that xy times the expression 1 plus x squared dy dx equals the expression 1 plus y squared. So I have questions of this nature. How are you going to solve in order to what? In order to obey the fact that xy multiplying this should be equal to this. The left hand side should be equal to what? The right hand side in this case. Alright. So let's see how we can solve for this. So solution. So we have 1 plus x squared times 1 plus y squared minus my p s squared equals 0. Alright. So first of all, what are we supposed to do? This expression multiplying this minus p s squared is equal to 0. Where p over here, p is a constant. And if you look at the question critically, you realize that I don't have any p component in the question here. They are saying show that I have xy, x dy dx, I have y squared dy here. Do you get that? I don't have what? Any p component or p variable in it. So I have to adjust this equation such that p disappears. But before I do that, again, I have to differentiate the equation implicitly. So how do I do that? I have x plus 1 plus s squared. So I have to differentiate this. So if I differentiate this, I'll have what? If I differentiate 1, I'll get 0. If I differentiate s squared, I'll get what? 2x. So I'll differentiate 1, then I'll what? And then I'll maintain what? The second what? Expression of the second term. I have plus what? 1 plus y squared. This way. Then plus. First I differentiated this and I kept this constant. This time around, I'll keep this as my constant and differentiate this. So I'll have what? 1 plus x squared then times this. If I differentiate 1, I'll get 0. If I differentiate y squared, I'll get what? I'll get 2 what? 2y. Because it is a term containing y, I'll add what? Y over the x. Minus p is a constant, so p just remains over the p. Then here, if I differentiate x squared, I'll have what? I'll have 2x. But you know, it's proper to do it this way. 2x what? P, which is equal to what? 0. This way. Okay, so I can label this as, that's my equation 1. So from equation 1, we have this. We have 1 plus x squared, then we have 1 plus y squared minus p s squared is equal to 0. Look at this. I don't have any x component in this. So I will make p what? The subject over here. I'll make p the subject over here. How do I do that? This is very simple. So again, I have 1 plus x squared times 1 plus y squared is equal to px what squared. We shape this to the other side. Then I'll divide both sides by what? X what squared. And divide it by what? X what squared. So s squared cancels what? S squared. So finally I have what? P is equal to the expression 1 plus x squared multiplying another expression 1 plus y squared all over what? My x squared. After doing this, I will substitute the expression for p into this so that I can eliminate p from the equation over here. So by doing that, so I have 2x, then I have 1 plus y squared plus 1 plus x squared multiplying 2y dy over the x. This we are only calling this. Okay. Then minus 2x. Whenever I see p, I put what? This is the p, the expression for what? For p. I'll just substitute p here. So p becomes the whole of this. So I have x, I have 1 plus x squared, then I have 1 plus y squared, all over x squared is equal to what? 0 is equal to 0. I hope you are following. So I'll have 2x times I have 1 plus y squared plus 1 plus s squared times 2y. I have my dy over my x minus viewers. This s squared, one of the x cancels what? The x over here. So I'll have what? I'll have 2 multiplying 1 plus x squared times 1 plus y squared all over what? All over my x is equal to what? 0. So for want of space, I'll just rewrite this on the other side and let's proceed from there. Okay, so on the other side we have 2x open bracket 1 plus y squared plus 1 plus x squared multiplying 2y over the x minus 2, then we have x, 1 plus x squared, then we have 1 plus y squared, all over what? On x is equal to 0. Viewers, this should be what? Denominator 3. So I'll multiply 2 by what? By x. That's the LCM, which is what? X. So if I multiply 2 by x, I'll have 2x squared. X multiplies this term, multiply this term, and multiplies this term on the other side. So I have bracket 1 plus y squared. Then plus, again, x multiplies this. So I have x multiplying 1 plus x squared, multiplying 2 y over x, then minus 2 bracket 1 plus x squared, 1 plus y squared. This way is equal to 0. But if I multiply here by x cancels x, I'll still get this. Alright. Now, let me group. When I look through the equation, I can see dy dx somewhere here. So I'll group dy dx at one side in order to avoid confusion. So I'll have 2x squared bracket 1 plus y squared. Then minus, then I'll bring this over here. So I have minus 2. Then I have 1 plus x squared times 1 plus y squared. Then I'll now bring this over here. So I have plus x multiplying 1 plus s squared multiplying 2y over dx, which is equal to here 0. 2 is common. So these 2 will cancel these 2 and will cancel these 2 since it's a common factor. So I'll have x squared bracket 1 plus y squared. Then I have minus bracket 1 plus x squared multiplying 1 plus y squared. Note that the negative is affecting everything here. So I have this one. Then plus half x bracket 1 plus x squared y then dy over x, giving me what? 0. Okay, let's see what happens over here. The expression 1 plus y squared over here and 1 plus y squared here. I can see a common factor. So I'll factorize the common factor over here, then proceed. So I'll have, so the common factor here is what? 1 plus y what? Squared. Is that not so? Then I have this way. So what I will do is, if the common factor 1 plus y squared cancels this, I have what? S squared over here. So I have x squared. Then I have my minus over here. My minus comes here. Then to bracket 1 plus y squared is a common factor. So to cancel this, leaving what? This. So I have minus 1 plus x squared. This way. Then plus I have x to bracket 1 plus x squared. Then I have y over the s is equal to what? 0. So again, what can we do over here? The question is saying show that x, y multiplying 1 plus x squared divided x is equal to 1 plus y squared. Alright. So I think you can expand this. You can work out for this. So I have 1 plus y squared into brackets. I have x squared. The minus will affect whatever I say. So I have minus 1, then I have minus x squared over here. Then plus I have my x into bracket 1 plus x squared times y dy over dx, giving me what? 0. So I have 1 plus y squared. Now we know that positive s squared cancels what? Negative s squared. So I have this multiplying what? Negative what? 1. Then plus x into bracket expression 1 plus x squared times my y, then dy over dx, giving me what? 0. Again, this is the same as the negative affects everything, or you can just do this way. You have negative into brackets 1 plus y squared, then plus I have x into bracket 1 plus s squared times y, then I have y over x is equal to 0. So I can allow this expression to cross. You get it that way. So if I transpose this, I'll get I have my x into bracket 1 plus x squared times y dy over dx, which is equal to, I'll get what? Positive 1 plus y squared. Multiplication is what? Is commutative. So by rearrangement, x times y becomes what? X what? Y. So I have what? X, y, then bracket, the expression 1 plus x squared. Multiplying what? Y over x, which is equal to what? 1 plus y squared.